BimRV is ODE's standalone toolkit for the import, visualization and creation of Revit models. BimRV includes support for the latest 2024 Revit file format. All the files from version 2015 onwards are automatically converted to the latest 2024 version during loading, giving client applications consistent access to data regardless of the underlying file version. BimRV can also write files to the 2024 format. BimRV provides read access for 100% of the data in a Revit model. In addition, it includes rich visualization that supports geometry, materials, visual styles, textures, and so on, greatly expanding the potential use cases where BimRV can be successfully utilized. Support for temporary and auxiliary element creation, such as plane and section views, annotation elements, cable tray geometry, and others, expands the set of use cases even more. Improvements to BimRV have been made in several directions: view control and navigation, documentation and detailing, data management and collaboration. We implemented the ability to enable/disable section box. You also can set up its size. So we enabled a command which shows the ability. You can select an element or several elements and enable the section box. The section box will be created by extents of the elements. Also, we added the ability to show or hide elements in the view. Elements can be hidden permanently, and these will be saved to the file, or they can be hidden temporarily, and it will not be saved to the file. We added the ability to draw grids on levels in 3D. Previously, grids draw only plane views. You can turn on a set of levels to visualize grids or only one. And also we turn off visible grids. We improved calculation of required settings and their usage in GSU for perspective views. Multi-crop regions feature allows to split crop regions into several crop regions. This allows you to cut off some part of the view, like on the right side, for example, view. Moreover, those regions could be shifted, bringing together distant parts of the view, like on the left side. Multi-segment sections is another multi-view example. Here in the example, you can see the view is split into 3 parts, each having its own front clip plane. On the leftmost part, there is a facade of the building. On the middle part, there is the inside of the building, and the rightmost part looks beyond the building. Ceiling plans are reflected plans which require many things to be reflected or flipped for these plans, like face orientation, fill pattern orientation, G-filter direction, clipping boundaries, and etc. You can see the examples on the screen. Schedules normally do not store data internally, but have different rules and settings for collecting data from elements. This year, we added the ability to create some schedules. Let's open a file and create some schedules with the example command. Here we have created a wall schedule, wall material takeoff schedule, area schedule, and view list. Currently, BimRV API allows the creation of a new schedule, setup fields, filtering and sorting conditions, and other properties for schedule definition. We also have the ability to walk through schedule cells and export them as CSV or HTML file as example. Let's do it using export commands, which are also placed in the BimRV examples. We also implemented a visualization of the graphic column schedule. It contains grid lines with their top and bottom constraints, and offsets and structural columns, placed between them according to its identification. Schedules also support calculations based on formulas. It uses formula functionality, which is also used in family types. For example, in this schedule, the cost field contains a formula as the quantity field multiplied by the price field. Also, a lot of improvements were done in panel schedules visualization. Different types of two-column schedules are supported. Fields, color, and so on. For families, we can create several family templates, all forms elements and the void form. These are base elements for creating families geometry. Family geom combination. This is a Boolean operation on form elements. Opening in host element in a family file. Dimensions and reference plane elements. This year, we implemented the ability to recalculate parameter value by formulas. Also, we can restore text representation of the formulas you can see in the dialog. We implemented the initial version of the ability to create formulas by text representation. And we continue to work on full support of group element, linear array, radial array. Currently, this is the main known restriction for regenerate family geometry. We implement the ability to create, edit, remove family parameters of any type. In the process, we try to recreate geometry with new parameters, and if we can do it, the parameter can be applied. Next important issue for families is the ability to update geometry by family type. In this process, we need move and update references because it can change parameters of elements. We use constraint solver in the process. Find elements which must be updated. For each element, we need to modify its parameters and run constraint solver to solve the sketch for a new state. If it is solved, the element geometry must be rebuilt for new sketch. And finally, create a graph of operations between elements and repeat them in the correct order. If all steps are done, we will get geometry for the new family type. This process works in family when you change family type, and it is also used for activation family symbols. In this case, we try to rebuild geometry in a restored family database and collect the result to the symbol. You also can restore the family database. Edit family method in the API should be used. You also can call it in the debug application. For import families, we can import a family into a model or family database and create an internal family database. Create new family symbols during input. Activate family symbols if we can rebuild the geometry of the family. During activation, we need to create the geometry of the symbol. And finally, we can create new family instances for activated symbols. Creating new instances for hosted families also requires modification of the geometry of the host element.